So let's take what we've done these past couple days and put it all together. And yesterday what we practiced on in class is writing inequalities to go with, so to speak, word problems. So the first problem here, we have a clothing company makes jackets and pants. And each jacket requires 1 hour of cutting and 4 hours of sewing. Each pair of pants requires 2 hours of cutting and 2 hours of sewing. The total time per day available for cutting is 20 hours and for sewing is 32 hours. If the profit on the jacket is $14 and the profit on the pair of pants is $8, write a system of inequalities to represent the number of items that can be produced to determine the number of each item that should be made each day to maximize the profit. Got a little wordy on that last bullet point there. But the first thing that I want to point out is when we were working on these, the introduction to these yesterday, the first thing that we wrote down is that X equals the jackets and Y equals the pants. And that's already stated there in letter A, if you don't want to write it down again. But the second thing that we did is we wrote down what the objective quantity equation was. And that is the money part of this. So what we did, I'm going to jump down here to part D, is writing a function for the total profit made on the clothing is going to be the F of X comma Y, F of X and Y. So when we look back at the problem, how much money are we going to make on a jacket? Huh? $14. And how much are we going to make on the pants? Huh? 8. So when we write this, jackets are X, so it's going to be $14 for a jacket. And the pants are represented by Y, so it's going to be 8Y. Again, look for the money. Look for the word profit. Those are two indicators to be able to fill in part D. And now we're going to go back and we're going to write the other inequalities here. And before we get going too far on this, remember that on our inequalities, if we're going to make some money, we have to assume that we're going to make some jackets. And we have to assume that we're going to make some pants. We might make all jackets and no pants. We might make all pants and no jackets. But we need those two inequalities in there for us to be able to graph the system and come up with our maximum and minimum if we need to value. So again, part A. Let X represent the jackets, Y represent the pants. Write a system of inequalities to represent the number of pants and jackets made. Well, let's go back and look. What two things are happening at this company? Looks like cutting and sewing. So we're going to have an equation that has cutting in it. And if you can, write them side by side. I'm going to write this part side by side, but I can't squeeze it in very well. There's the two things happening. So we want to write an inequality that has cutting in it. We want to write an inequality that's just sewing in it. And we're going to use those to help us in a couple minutes. So when we go back again and look at the problem, it says each jacket requires 1 hour of cutting. Well, jackets are X. 1X. Well, how many hours of cutting does it take when we're working with pants? Looks like 2. Am I right? Pants are represented by what? Each pair of pants requires 2 hours of cutting. How many total hours do we have for cutting? Huh? We've got 20. The total time per day available for cutting is 20 hours in that next to the last bullet. Less than or equal to 20. Now, again, if you can, write it side by side. I'm going to leave some space here because I can't fit all of that in. We're going to have to put these inequalities in slope-intercept form in a couple of minutes, which is why I'm scooting down here to do the sewing. So sewing our inequality. Well, how many hours available? So how many hours does it take for us to sew a jacket? We go back to the first bullet and it says it takes 4 hours of sewing. Jackets are represented by X. How many hours does it take to sew a pair of pants? We go back to the second bullet and it tells us that we need 2 hours of sewing. Pants are represented by Y. And how many hours do we have available for sewing? Well, the total time per day available for sewing is 32 hours. So we have to keep looking back in the problem to find what we need. Well, now, that's what we did yesterday. What we're going to do is we're going to put these two inequalities into slope-intercept form. The y equals mx plus b. So we're going back to our blue equation. Hopefully I left myself enough space. We're going to subtract 1x from both sides. And we have 2. Y is less than or equal to negative 1x plus 20. Well, it's 2 times y. We're going to divide then by 2. And our inequality now is y is less than or equal to negative 1/2 x plus 10. Once we have it in that format, it's in the slope-intercept format, what's b in this inequality? 10. Which means that our slope is going to be negative 1/2. And we're going to graph that in a minute. But we also need to look at our sewing inequality, and let's put that in slope-intercept form so that we can do all the graphing at once. Same kind of idea. We're going to subtract the 4x from both sides. And we have 2y is less than or equal to negative 4x plus 32. Well, it's 2 times y. We're going to divide everything by 2 now. And when we divide everything by 2, we end up with y is less than or equal to negative 2x plus 16. From there, what's our y-intercept? It's 16. And our slope is negative 2, which we might want to write down as negative 2 over 1 because we're dealing with rise over run. And now we've got what we need to graph. Going to start here with our purplish inequalities. Remember that x is greater than or equal to 0 has to cross the x-axis. So this is a vertical line. And then we have to cross the y-axis for y is greater than or equal to 0, which means that that is a horizontal. And do the best you can. If you're writing in pencil, it's going to be a little bit harder on here. Some people like to put a highlighter on this part, but here's our vertical. And I'm trying to darken it in a little bit. There's x is greater than or equal to 0. Well, it's x equals 0. And then we've got our horizontal here, which you might have to go over a couple times. And it makes sense, because we cannot make negative pairs of pants or negative jackets. So we need to be working in the first quadrant. But we've got 2 more to graph. And the next one's going to be the blue. And we already have determined that b equals 10. And our slope is negative 1/2. Down 1 to the right 2. 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 Again, I'm drawing freehand, so I like to put in a bunch of points. It helps me for another reason as well. But most of you have a ruler that you can use to help draw that line. And now we're going to graph the green inequality. We said that b equals 16. We graph b before m because b comes before m in the alphabet. So here's the 16. And our slope is negative 2 over 1. So this time we're going to go down 2 to the right 1. 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 And down 2 to the right 1. And crooked, but it'll work there. But remember, with inequalities, it never says shade. That is implied in the problem that we need to shade. So we're going to go back to our 2 purplish colored lines. And it says x is greater than or equal to 0. Well, that is our vertical line. And where we would shade, and we really only have one option here, is going to be to the right of that. And I'm just going to shade a little bit. And maybe you want to wait to shade until we get this all together. But it's the same thing with y is greater than or equal to 0, our horizontal line. Well, we really only have one place to shade, which is above there. But for our blue line and our green line, I'm going to squeeze it in here. But let's pick the value of 0, 0 here on our graph. I'm going to squeeze it in. It's going to be small. But I'm going to put it back in here. 1 times 0 plus 2 times 0. And the question is, will that be less than or equal to 20? Well, 1 times 0 is 0. 2 times 0 is 0. Is 0 less than or equal to 20? So we're going to shade where the x is, the black x is, which is kind of underneath. And for some of you, you just see it. Some of us don't just see it. If you can intuitively graph that, that's fine. Let's do the same thing with the green, and I'm going to squeeze it in as well, and I'm still going to pick 0, 0, because we pick a point that's not on the line, and 0, 0 is not on the line. So 4 times 0 plus 2 times 0, and the question is that value less than or equal to 32? Well, is 0 plus 0 less than or equal to 32? Yes. So we will shade where the x is, which is kind of to the left of that green line. And it gets a little bit jumbled, but what we're looking for is a convex polygonal region. And where that convex polygonal region is in here. Right there. And once we can identify that, then we can get the rest of the problem. Because we still have some pieces left here. We've done part B now. We graphed the graph showing the feasible region. And a reminder one more time is, with inequalities, we need to shade, and it never says shade. So that leaves us to part C here, which says list the coordinates of the feasible region. So when we go back and look at our picture a little bit more closely, we've got an ordered pair here. We've got an ordered pair here. We have an ordered pair here, and we have an ordered pair there. And we need to list them. They do not need to be in the same order that I list them, but you do need to have all of them listed. So we have 0, 0. That was the first one that I filled in. We can go over 0 up 10. So 0, 10. We can go to the right 8 up 0. And then our last one is over 4 up 8. And now that we've identified those, that's going to allow us to answer our last question here, determine the number of jackets and pants that are needed to make a maximum profit. If we're going to sell things, we want to make some money. So we're going to take our objective quantity equation. That's our f of x comma y equals 14x plus 8y. And we're going to put in our ordered pairs. Well, we're going to start with 0, 0. 0 is going to go in for x. 0 is going to go in for y. And when we do, 14 times 0 plus 8 times 0 is 0. Our next point is 0, 10. And we're going to put 0 back in for x and 14 back in for y. And when we type that in our calculator or we mentally do the math, we get 80. Next value is 8, 0. These are just the values that we listed in part C. F of 8, 0. So we're going to put 8 back in for x, and we're going to put 0 back in for y. And we end up with 112. And our last value is our 4, 8. So we're going to put 4 back in for x, and we're going to put 8 back in for 8. And when we do the math there again, we might have to type it in. We end up with 120. Well, that doesn't answer the question on part E. Part E now says, determine the number of jackets and pants that are needed to make a maximum profit. And then what is this profit? Well, we go back and look at our values, 0 and 80 and 112 and 120. Our maximum value of those 4 values is this 120. So yesterday what we had to do, or 2 days ago, what we had to do is we had to write down, well, what is the maximum value? And then where? At what order pair? Well, what this tells us is, remember, X are the jackets. We're going to have to make 4 jackets, and we're going to have to make 8 pairs of pants for us to make the most money. And the amount of money that we're going to make on that is going to be $120 of profit for that combination. Let's flip over the page.